Hello, everybody, and welcome to yet another Clarity for Climate Resilience webinar. This one is at the same time also Climate Thursdays webinar, which is a combined action with some other projects. And both of these series have very similar goals, which is to talk about the marketplace for climate services, to talk about the impact of climate change and the adaptation options one can use to work against this impact, and also to talk about both the policy and the technology. The Climate Thursdays, as the name says it, always on Thursday every week. There will be a break somewhere in beginning of August, but we will be back. Then the Clarity for Climate Resilience are a little bit different. They're usually on Wednesday. This one is special since it's shared with Climate Thursdays, and they can also be in many languages. So we just had one in German, which was really excellent yesterday. And next week we will have one in Spanish and one in Italian. Now, panelists. I am Denis Havlik. I work for AIT, Austrian Institute of Technology in Austria, and I am leading the Clarity project. Mattia?
Hello, I'm Mattia Leone from the University of Naples, Plinius Study Center. I'm an architect working on climate change adaptation at building scale and urban scale.
Andrea?
I'm Andrea Geier-Scholz from Smart Cities Consulting based in Vienna. I'm partner of the Clarity project, responsible for dissemination and distribution, and I will man the back office in this webinar today.
Claudia?
Hello, I'm Claudia Hahn. I'm working for the Austrian National Weather Service in the urban modeling group, and we are involved in the Clarity project as well. So modeling pollens and providing climate information for the whole of Europe.
Wolfgang?
Yes, hello. I'm Wolfgang Leury, working for AIT. I'm an urban planner and specialized in climate adaptation in urban environments.
George?
Hello, my name is George Amorim. I work as a researcher at Swedish Met Office, and I focus on urban air quality and urban climate, and will be presenting some results that we obtained for Stockholm under the scope of the Clarity project.
And last but not least, Robert?
Hello, my name is Robert Gola, and like Claudia, I work at the Urban Modeling Group at SAMC, which is the Austrian Weather Service based in Vienna. We worked on generating the European-wide climate indices, which we'll present today, and which are used to assess the current and future climate hazards.
Andrea has already started this poll. We would like to see who is really with us today. We do have your information from registration, but not everybody is here just to see who we are counting with today. Oh, we are working mostly with scientists and developers today. Good to know. Good. Let's go to the actual presentation. Robert, you and I stay here for the beginning. So first part of the presentation is about the current situation with heat in Europe and what we can expect about it. Let's start from the bird's eye perspective. So if we divide the Europe in some major climate zones, we can see that unsurprisingly, the Southern Europe is most affected by climate change. There will be issues with drought. There will be even higher risk of forest fires. There will be a lot of heat extremes and mortality. to the point where summer tourism may suffer, where crop yields may suffer, and where potential for energy production may. If we go to the north, Atlantic region has mainly the issue of heavy precipitation events, and they are lucky in a way that they will have less energy demand for heating in winter. What it doesn't say here is that they may have problem with heat because of the architecture they have, with big windows where at the moment in summer when there are a couple of warm days, it's getting really very hot in those houses, and they will need to do something about that. The continental region is, well, as we know, cold winters, warm summers. Cold winters are going to be somewhat less cold maybe, but more changing. Also, the summers are going to be changing from very strong precipitation to extreme heat and weeks without any rain. So we will start getting more risk of forest fires, risk of river floods will even increase, and in summer, the cooling energy demand, unless we do something nice with our cities. Interesting part, boreal area and mountainous regions, they have some similarities, but the big difference is that in mountains, when it starts getting hotter, any species living there will move up, 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 and then they will not be able to move anymore, so they may die out. Skiing tourism, well, we already had problems with it, and it's not going to get any better. Glaciers, which is a problem with water downstreams. In the boreal region in the north, they may even have some positive effects, so less energy demand, nicer summers with tourists coming there, but it's not all fun. They will also have similar problems as on Atlantic. Their architecture is not made for hot summers. There will be also, we have seen that already happening in Finland. They got some forest fires, which is quite unexpected. So it's a mixed bag for that. And now this is the interesting thing to see. Is the global climate changing, Robert?
Yes, so thank you, Dennis. Yeah, so basically to understand how the global climate or why the global climate is changing, if we look at measurements shown here on the left-hand side of carbon dioxide concentration in the atmosphere. Now these measurements since 1960 until present have shown a steady increase starting from around 320 parts per million, going up to the current rate of around current level of around 410 parts per million. So basically at the moment we're increasing at a rate of about 2 parts per million per year, and this is due to all the burning of the fossil fuels releasing the stored up carbon into the atmosphere. Now during this time, over the last 70 or so years, the average global temperature has increased by about 1 degree in this time frame. Okay, so we need to understand this when we want to look at how the future climate will look like. And so to assess how the future climate will look like until the year 2100, one usually employs climate models, and they need to know how the concentration of carbon dioxide in the atmosphere is predicted to change into the future. And what I've shown here are 3 typical scenarios which are used for climate modeling studies. The first curve here in green shows an early response for the humans. So this is taking into account how the humans will develop in terms of quickly changing over their fossil fuel use and swapping the energy production in terms of renewable energy sources, such as wind power or solar power. And under such a circumstance, one would see then the concentration of carbon dioxide decreasing towards the end of the 2100 to around 400 parts per million. And Under such a circumstance, climate models typically only have a temperature increase of around 1 to 2 degrees, globally averaged. Now, on the other hand, it is possible that in the future, we will continue burning fossil fuels as we are at the present level without taking into account any renewable energy sources. And this will then be the concentration of carbon dioxide in the atmosphere will then follow this red curve here. And this is described as a worst case scenario. And climate models have an average global temperature increase of around 3 to 5 degrees. Now, at the moment, the way things are looking at, we're sort of trending towards a curve which is just below the RCP 8.5. And so this maybe, if we're lucky, we can follow this effective measures where it takes a bit of time for us to change over our fossil fuel producing energy sources to more renewable energy sources, which would result in a more moderate temperature increase. And so these scenarios are coded with the value RCP 8.5, so representative concentration pathways. Okay, so in the results that I'll mainly show this extreme case, sort of as a bit of a shock to show what would happen in the future for Europe if we didn't do anything. Okay.
So Robert, wait for a moment. There is something I often wondered about, like, yeah, okay, it's gonna rise 1, 2, 3 degrees. Who cares? Like, are we all gonna die because 2 degrees more? Why do we even care? People are living in places which have 2 degrees more or less. So what does it matter?
Exactly, you're right. I mean, it sounds not that much, but when we think about it, we're talking about an increase in the average temperature. So what this means is that although the average temperature will only increase by about 2 degrees, this means that the extremes that one experiences, so we have to remember it's the extreme temperatures, like the maximum temperature on the day, which results in deaths. These extremes can increase by more than 2 degrees. So extreme cases to 5 degrees, 6 degrees. Okay, so it's these individual events where we have a larger temperature increase than the average. That's the events which result in deaths. And so that's why, although a 2 degree increase in the average sounds not that significant, we have to think that this is actually, in terms of the extreme temperatures, results in a greater increase. Okay.
Yeah, and we are still not all going to die, but it could be quite expensive, right?
Exactly, it could be quite expensive. And the way humans generally work, we come up with solutions to mitigate these effects. And with a larger temperature increase, it just means that we need to increase our investments in the adaptation options to mitigate these effects. Okay, so that we can...
I'm leaving you to present the rest of this now, so have fun.
Okay, thank you, Dennis. If I can go forward. Oops. Here we go. Yeah, and so the goal of Clarity is to help understand what these climate changes mean at the regional and local scale, and particularly what we can do about them. So we can see that obviously there's going to be a temperature increase in the future. Well, what adaptation options can be put in place to mitigate these effects? And so that's what the role of Clarity is, to help see how we can mitigate these effects. Now, to do this, Clarity has generated a number of climate indices which assess the hazards for the future, and these are available on the climate system that we've provided here. So in total, there are at least 20 indices available related to, for example, heat waves, to extreme temperatures, both hot and cold, to precipitation and droughts and flooding. And so what I'm going to present here is just a subset of some indices relating to heat and heat waves. And the first index which I'm showing here is the number of hot days per year where the daily maximum temperature exceeds 30 degrees. And on the left, we basically have a sort of a current situation, so a yearly average over this 30-year period from 1971 to 2000, showing how many hot days are typically observed at the moment. So we can see that in terms of the colors, it's mainly around the Mediterranean region where they have heat. And on the right, we're showing here an animation stepping through the four time periods here. once again taking the extreme emissions scenario case. So this is where we do our business as usual and keep burning our fossil fuels to generate energy. And what we see towards the end of the period, a map dominated by the red colors, so showing a large increase in the number of hot days which will be observed in Europe. Now, to put these values into its perspective, okay, so hopefully we can all remember the severe heat wave in 2003 in Europe, which resulted in an estimated 40,000 additional deaths across Europe. And this is showing here the number of hot days which were observed in that year. And so if we compare it with the last time period here in this animation, which has stopped. Here we go. Oops, enough quick going back. We can see that in the last slide here, we're having values which exceed this extreme heat wave which we had in 2003. Okay, so we see how severe this heat wave was in terms of the population. In this scenario, for the future, we'll expect much worse conditions, much hotter conditions. Now, the previous index was concentrating on an absolute value of 30 degrees. Now, such a value of 30 degrees is not typically observed in the northern part of Europe. And so this is where other indices need to be implemented. So in this case, we're looking at a relative index where we're looking at the number of days which exceed the 90th percentile of the temperature on a day. And so here we see that indeed all of Europe will be affected by heat in the future. Okay, so not only the southern part, but also here in the northern part of Europe. Now, this is just two indices here. Now, just quickly going through a couple of other indices here. One important index refers to the tropical nights. So this is looking at the number of days where the minimum temperature exceeds 20 degrees. Now, of course, in the night, it's important for the body to recuperate after a hot day. As long as the night is cold enough, generally the body can recover and sleep well. But in cases where the nighttime temperature remains high, then this affects sleeping quality, results in restless sleep, and then this can lead to knock-on effects such as increased work accidents during the day. And so it's important in this case to be able to air out the apartment or a house during the night to let in cold air. And so here we can see in this scenario a large increase in the number of tropical nights, particularly around the Mediterranean region here. Now on the right-hand side here, we're looking at a 7-day heat wave event, which occurs once in every 20 years. So this is basically considered to be a not so frequent event, looking at what the maximum temperature is for such an event. And here, perhaps the scale is not readable, but here the reds represent temperatures of around 35 to 37 degrees on each of these 7 days in this heat wave. And what we see here for the future in this scenario, that for example, for France here, we're looking at temperatures which exceed 39 to 40 degrees for all of these 7 days in the heat wave. Now, just comparing it with the 2003 heat wave for France, where around 14,000 people alone in France died, there it was recorded that for a 7-day period, temperatures reached up to 37 degrees. Okay, so 37 degrees is here, this yellow to light orange color here. And as you can see here on this map here, we're showing colors which are above 39 degrees. So that means that in such a scenario, we would expect basically mortality rates exceeding what we had for the 2003 heat wave in Europe. Okay, so this is just a number of some of the indices which are available on the Clarity website. And now I'll pass over to the next speaker, Claudia, looking at part 2 of the webinar today. Thank you.
Yeah, thank you, Robert. Okay, so as Robert already said, the indices that he just explained, they are available in the Clarity screening tool, which offers a basic and an advanced screening to analyze the heat hazard. And I'll focus on the basic screening, but before I do that, I also want to quickly introduce you to the tool itself. So the Climate Adaptation Service or screening tool is available online, as you can see here, and it allows for an EU-wide automatic screening of climate risks. And if we to enable an automatic screening, it's necessary to have a robust and standardized methodology. And the methodology that was applied here was based on EU guidelines and was updated to also comply with the 5th assessment report of the IPCC. So now we have this workflow that you can see here, which consists of 7 steps. So first one has to characterize the hazards that affect the area in question that one is looking at. In the second step, one has to analyze who or what might be affected by the hazard and where are these elements at risk located. Then it's necessary to identify or to investigate how susceptible these elements at risk are. And all these steps are necessary really to perform a risk assessment or impact assessment. And the last 3 steps of this workflow, they comprise the identification, evaluation, and implementation of adaptation options. So the Clarity Climate Information System now guides the user through all these steps, and it provides an easy access to publicly available climate data, kind of the data that Robert just presented, and also to land use data and information about adaptation measures. And as mentioned before, it's possible to perform a basic and advanced screening. For both screening options, there are the climate indices and additional data sets that you can see here. So these are land use data sets or digital elevation models that are available on Copernicus. So your imperviousness layers or Korean land cover or also urban atlas layers. And in addition, there are also 13 Clarity high resolution land cover layers, which were produced within the Clarity project by combining openly available data sets, the European settlement map, the urban atlas, and the street tree layers. And the advantage of these high resolution layers can be seen here maybe, because here we can see the airport in Linz or just outside of Linz. And in urban atlas, this whole region would just be classified as airport. And now with this layers here, it's possible to identify small buildings and to see where there's paved areas and where there's just grassland, for example. So these layers help exploring the area one is interested in. And if I now go to the basic screening, and here the first step for the hazard characterization, we have the climate indices that Robert presented, available for one historical period and 3 future time periods, and for the 3 climate change scenarios that Robert explained before. And what you can see here is that the resolution that is available here, it's 12 times 12 kilometer. Well, it's too low to resolve urban structures, and thus too low to account for the urban heat island effect or to account for the variation in temperature which is caused by small-scale urban features. But what one can see here is that the climate will change by quite a bit. Here I've taken the number of hot days for the historical period and for a future time period, and there will be an increase. Now it's possible to kind of make an overlay of the different data sets that are available in the system to estimate where the temperatures will be even higher due to this urban heat island effect. And for this here, just as an example, I took again the hot days for the historical period and the imperviousness layer that's available on Copernicus. And if one overlays these two, you can see kind of where Linz is and where the paved area is, and so also where it will be even hotter during the day, at least because of the absorption of energy. It's also possible to take other layers to investigate this, like the dense urban fabric or industrial layers, kind of the buildings that we've extracted. And here you see as well, it's again the Linz, and these areas will be even hotter, probably also during the night, because the long wave radiation will be trapped in urban canyons. It's also possible to make an overlay of these data sets to analyze the exposure. And for this, one has to kind of have a look at the additional layers again that are available and which ones one could use as a proxy for population in this case, if we want to have a look at heat. And so here I've again taken for the hazard layer the hot days, and then we'll show you here the urban fabric layers. And here only the buildings that are located in the dense urban fabric, median urban fabric, urban fabric. So here are those buildings where people live. And if you overlay them, that's how it would look like. It's also possible to take other layers that are available on the Copernicus website, like the land uptake per person. And here just one has to be careful that the darker color illustrates the areas where less people are. Okay, and here it's obvious, here is where people live, so they will be affected by heat. And the screening tool also enables us to see how it all will evolve in the future. So now we have the static information regarding imperviousness and buildings, okay, that one has to keep in mind, but it's still possible with this to see where will the heat be more extreme and how will it evolve from the past to the future, and where are the elements at risk, in this case the people are located. So if it's if it's hot here or in Linz, mainly these areas are kind of affected because here are the people that have to deal with the excess heat. So what is available as well in the system is a list of adaptation options, which can help the user to have a look at different options and to assess the costs and possible co-benefits as well. And we also have the twins opportunity. Here,
Now,
again.
what Claudia is showing till now is mainly really data. The climate indices which were calculated and the land cover indices which we inherited and in some cases improved. That's nice. That's a good thing to have if you are like Claudia, an expert who can understand what that means. But frankly, it's not very easy, not very tangible for people who are not. And this is where so-called twins come in. These are examples of events which happened in the past, of projects which were already planned or already exist, also of future predictions with explanations. And if we are talking about Clarity online tool, the point of that tool is mainly to be able to prepare a report. And so this kind of information can be added in a report together with the kind of information which Claudia was showing, which makes the whole report, let's say, easier to read and easier to understand. If I have a message to say, I can add some examples so people who are not experts, they will understand it better. So to summarize what we have from this simple screening, Claudia?
Yeah, so it's mainly a qualitative risk assessment. So we have the opportunity to have a look at the hazard at a low resolution, but still it tells us something. We can investigate exposure using maybe proxy data, and like this can estimate where the critical areas in our region of interest are. There's also a list of adaptation options which we can have a look at in order to evaluate which ones might be of interest for us or for the user. And there are additional information where we can learn from other projects that already were carried out.
So I would claim that the main advantage of this is just inconvenience, because everything is there, everything is nicely structured. You can just go step by step and you have your report. There is nothing that special new in it. It's well, our indices are not available elsewhere, but it's free data, they will be. But it's just convenience. But let's see, we can do better than that, right? So
let's go to the advanced
next
screening.
part, advanced screening.
Yes, thank you, Dennis. Yes, the Clarity climate services include two more level of investigation. One is the advanced screening, which is still available online, and another is the expert service, which we perform, let's say, offline by connecting experts from a variety of scientific domains which are relevant to support urban adaptation planning for heat and other climate-related hazards. In this scheme, you can see the logic of the two models. One of the critical information for urban decision makers working on climate adaptation is, of course, going a bit more on detail compared to what climate information usually gives us in terms of resolution. So that's why we have been developing a model, a specific model, able to identify the urban microclimate variables and compare and read the effect of climate change on different part of the city. This detail is further enhanced in the expert level by using a variety of tools. So I will be briefly showing these two, and the second one will be applied to the case of Naples. So we have already learned that Clarity basically works with open data which are available at European level, mainly from Copernicus, Eurostat, and other reliable, of course, sources. What you have seen in the basic screening has been further developing the advanced screening, because all this data have been extracted and specific features have been assigned to model with the critical parameters which imply different urban microclimate conditions. So looking about heat, these are some of the variables that we have been able to derive from the information depicted from a wide range of data sets. So this is what the platform look like, because this is going also to be available through our myclimateservices.eu website. And as Dennis was saying, helping in generating reports which are guided by the platform, but can be customized by the user depending on specific needs. So is a process of addition of information within the report with some personalization feature, especially for what concern the layers you want to see in the maps, the kind of scenario in terms of future RCPs or future time frame or frequency of events. This is how the platform look like, but I want to focus on the main feature that we, let's say, are proud of. You might be familiar with most of the climate projection, those scaling at regional level, namely the Eurocordex or the MedCordex data, which usually have a resolution of 12 kilometers. This means that for the purpose of urban adaptation, these are, of course, very useful and fundamental piece of information, but they do not depict the specific microclimate condition that occur over a city because of the diversity in terms of land use, or even just because of the specific orography of some part of the city. All these features, let's say natural environment and built environment, of course, impact on the sort of aggravation. What we know as urban Italian, for example, is of course mainly caused by a combination of local microclimate features and especially the features of the urban environment. The Clarity Advanced Screening is able to depict relevant indicators, other indicators. In this case, we see the mean radiant temperature, which is a common proxy to identify the outdoor heat comfort of population. Over a cell overlapping on territory of a resolution of 500 meters. This means that we are already start to having some information which can guide urban adaptation and urban planning with a very specific. You see here a portion of the city of Naples, and you can see that these values are, of course, quite different depending on these features all over the city. this is available for many cities in Europe. I'm Italian, so I've put in this slide some Italian cities, Napoli, Bologna, Palermo, and Genova, but we have basically this information is available for every city which is covered by Urban Atlas or Eurostat. So a lot of cities in Europe are available. You can see here that you can choose the type of scenario. You can set up the scenario. So, for example, these screens you're seeing here are related to RCP 8.5 projection for the period 2041-2070 for a heat wave, which we classified as occasional. We understand all that as climate change, let's say, continue to cause effects, the frequency of event is of critical relevance. We will see more and more, let's say, 1 in a 20 year return period event, probably more often. So we should, there is also discussion on whether maybe to change the naming of this returning period, because we are actually experiencing this occasional event even with more frequent. So that's why we prefer not to call it like one in a year, 1 in 5 years, but we're simply calling it frequent, occasional, or rare, and led to the decision makers the choice of using these as baseline information to produce the scenarios. What is important that we perform a validation of this model based on a comparison with other very well documented documents available in literature, as the Solveig or Envimate solution focuses specifically on heat. We get very positive result in this validation process that makes us, continue with the choice of publishing this tool. So here is the shifting from, we've seen in the basic screening, we were just overlapping the hazard basically with a set of several layers to support information and awareness on climate information from end user side. Here we are working on a quantitative assessment. Quantitative assessments means that we are basically working on 2 indicators. One is the mortality rate increment due to the heat wave events, and another is the urban thermal climate comfort index, which helps in identifying the level of heat stress for population in different areas of the city. And the latter is also connected to the risk and the economic impact in terms of hospitalization costs that arise, especially for strokes or respiratory disease connected to heat. So here you see always our platform. So these are screen solution with the information on the mean radiant temperature on one of the mortality rate increment on one side, and the distribution of land use. This is very much connected, of course, as Claudia was anticipating, with the density of population in an area, because you can imagine if I get very high hazard data, but I don't have population living in a specific part of the city. For example, this usually occurs in airports, which are very critical in terms of heat, but people do not live there. So the information about quantification of risk and impact is of utmost importance to orient the urban adaptation policy. In the advanced screening, also the adaptation, which is currently under integration within the platform, it's a process of guiding you through the choice of the adaptation option and measures which are more suitable to reduce the heat wave stress in your city. In the system, we have 3 to 5 adaptation measures which are classified for buildings and open space, and we have grouped them into adaptation strategies, which are land use based, in the sense that the selection of the strategy is facilitated, and the effect of the integration of adaptation measure and so the variation, for example, of land use in a given area of the city is calculated so the difference in terms of impact, so the potential reduction in terms of the mortality rate increase, or the potential improvement in terms of a reduction of heat related stress for future scenarios. So the relevant information is coming to the end user also in a form of technical sheets, which highlights the impact in terms of climate benefits and co-benefits, especially because we know that urban decision makers are struggled with a lot of variety of priorities, which are not only limited to climate. That's why for us it's very important to convey the connection with co-benefits in terms of social, economic, and environmental co-benefits of adaptation as a support to mainstream urban regeneration oriented to climate adaptation. As a further support, we have introduced a showcase section. Basically, it's a portfolio of relevant architecture and urban projects in Europe and beyond, which features a series of adaptation measures and strategies. So these are integrated. Most of the solution perform not only one measure, of course, but what is useful is to have a combined reading from a project to come back to the technical adaptation measure. So to learn from what has been realized, the effect of those, and also to be able to directly connect with their adaptation measures. So basically, this is what we can provide at the end. The land use based adaptation strategies, once these are chosen and designed, can be applied to the system, and the calculation show the variation in terms of expected, for example, mean rate and temperature values, but at the same time, it also given information about the costs. So this is, again, an example on Napoli case. We have been targeting the ideal strategies toward 2050. This can be useful, for example, for strategic planning purpose, or to check how much would it cost to meet the very ambitious 2030 and 2050 agendas for Europe. And you can see here there is a quite huge cost, but we also know that these costs are real. So we could have backup information for in terms of a ratio of expenditure for adaptation in comparison to the GDP. These are information which is widely acknowledged, for example, since the Stern report on economics of climate change. So we are even quite confident with this kind of economic result. The good thing is that, as I was saying before, the user is prompted with a simplified selection of adaptation strategies, not to go measure by measure and applying that, but applying to each of the cell of the city in the study area that you have chosen. In this case, the study area is the whole city, but you can of course choose only one neighborhood or a district, and you got the backup information. So the advanced screening is really a plus compared to the basic screening, and it's already, through its automatically generated report, an incredible powerful information in the hands of decision makers, of policy makers, and also of designers and planners. And if we further want to deepen the level of information and quality of information, especially of quantification in terms of impact assessment, we need to go offline. So while everything we have seen until now is provided on the My Climate Service platform, on the web-based solution, the expert studies are for us the relevant community that can be created around clarity in terms of provider of solution, owners of models, owner of climate intelligence, owner of urban adaptation strategies, and users that need to address specific problems in their city. It means that here, all the kind of analysis are much more tailored to the needs of specific end users. In Clarity, we have done this on 3 or out of the 4 demonstration cases of the city. I'm introducing here the case of Napoli city, where we have been asked by the municipality of Naples, which is partner of the project, to support them in a sort of multi-scale climate resilient urban planning approach. They are committed at 3 levels. So they are working on the Sustainable Energy and Climate Action Plan, which is related to the Covenant of Mayor for Climate and Energy in Europe, so strategic planning level, but also the update of the Napoli City Plan and even more detailed district level urban regeneration project. So the main concern is to provide a current information across all of the scales And the fact that we basically can manage the same approach across the scale, it's very relevant because it already provides an horizontal and a vertical coordination among the policy makers, which are all taking this decision and documenting their plans and programs with the same, let's say, language and the same methodological approach. What we can see in Naples, yes, in Naples we are going to suffer a lot the effect of heat wave. Actually, we are already doing. We have been able, to the help of ZAMG, to identify specific trend for heat wave in Napoli, and you see how they are actually growing constantly in the future, especially and with very, very high temperature. We also discovered that if we look to the mean radiant temperature and we want to focus on the worst case scenario likely to happen in the future after 2050, basically the whole city is in danger, and action needs to be taken now to have some effects. The good news is that the municipality of Naples, and you can see here how compared to the advanced screening, we are now improving the resolution 250 by 250 meter. And of course, our model here are based on a much more detailed land use information, which is coming from the city level itself. So it's not the urban atlas, is much more refined, and we are able to provide much more fine-grained result. The good news is the municipality of Naples used this information and already embedded into the official document for the planning. The UTCI information is, say, the discomfort level. So as you can see, the situation is going to be very, very critical, especially in 2050 on. We have been also exploring the effect of climate change and heat variation across the year in terms of variation of energy expenditure for heating and cooling. So if the good news is that we are going to have a quite interesting saving in the winter period because of reduction of heating needs in Napoli area, is also true that in the future with the summer, the need for cooling in summer is going to increase a lot, and that's a really critical information which is going to impact on the local economy dramatically, and it's taken seriously from the city. Here just briefly showing, to conclude, different levels of deepening of this information, because for each of the cells that you have displayed in the above city level mapping, we can further analyze and looking at how specific morphology, urban morphology, or building and open space relation are triggering different heat hazard condition. So we understand more in detail why the previous cell is depicted in red. This is red due to the building features. This is red because of maybe extensive sealed open space with limited greening, urban greening level. That's another piece of information which, going down on a more urban design level, it's needed to inform the adaptation planning. In terms of adaptation options, we have been working in a co-design process, both with municipality experts and city officials, both for what concerned the district regeneration plan with the community. And as I say, this is very much related to the understanding of the relation between climate adaptation and the co-benefits for communities arising from this kind of urban regeneration approach, which look at climate resilience. When we go out to the most detailed level of information, we can give up to this three-dimensional information about UTCI and mean radiant temperature, and alternative solution for building use and building technologies, both for envelope and HVAC systems. This is intended to support the planners and the designers which have been appointed by the municipalities in validating or informing them about the result of their planning choices. So we are actually constantly updating this scenario and having an exchange with them for them to check the best solution for this neighborhood planning. This is an ongoing work that is going to happen in the also as a follow-up of Clarity, both in terms of the strategic city plan and the urban regeneration project level. So we are committed to continue supporting the municipality even after the project is going to end, given the criticality of these steps for our city. There is an interesting also implication at national levels. We are now in the process of negotiating with Europe, as all countries in Europe, the next 2021 2027 cohesion policy funding. And the idea is to use Clarity tools to support this knowledge in terms of which is the Italian situation for all the Italian cities, and which might be the needs in terms of adaptation, in terms of public investment need to improve the situation. So here I conclude just showing the multi-level opportunities arising from the use of Clarity Climate Services and the relevance of a quantification of impact from different climate hazards. We have now presented the heat in Naples, and there are some other cases which are following next.
So hello everyone, thank you Mattia. And what I propose you now is a journey up north, and I will be trying to very shortly present you some results of an expert study we did for the city of Stockholm, the capital of Sweden. and well, as a context, I will try to show you two main aspects. One is climate change signal at this high latitude. So is there a problem with heat at these high latitudes? What you can see in the two maps, these two maps on the, sorry because I have, okay. These two maps on the left show observations to time periods in the past. And this is showing days with mean temperature above 20 degrees. You may think that this is not a very high temperature, but first this is mean temperature over this period. And then you have to account the vulnerability of population, which is different from the city that we have just seen, Naples in Italy. So for a lower temperature, vulnerability is higher. So with that in mind, you can see that there has been an increase with the days, with these warmer days with mean temperature above 20 degrees that has been observed. Then in the middle, you see the year 2018, which was quite hot. So we had a very strong heat wave. When you compare this with the two maps on the right, which showed two climate projections for the future, two different scenarios that Robert explained in the beginning, you see that 2018 could have been a glimpse of what we will probably see in the future, and probably lies in between these two scenarios for the future. If we look at some observations for different years in the past with heat waves, you see that the red line shows 2018, and these are the days with max temperature exceeding 30 degrees. So this is very hot wherever you look at. And these are different municipalities. In the middle, the peak is showing the region of Stockholm. And you see that in this region, 2018, we had around 20 days exceeding 30 degrees. There was shortage in water resources, there was significant forest fires, and there were also death, additional mortality that the health agency estimated around 700 people that died as a consequence of heat. That is one aspect, is climate change, warming climate. The second aspect is urbanization. And this is not exclusive for Nordic countries, of course, this is a worldwide phenomenon. If you see these official data The blue line is showing the Europe a long time from the 50s. And this is the urban population. So we are becoming more and more into urban, living in cities. And if you look at the red line, this is Sweden, so following the same tendency, but it's quite a lot of urban population. In fact, we stand nearly 90% of population is already living in cities in Sweden at the moment. If we take Stockholm, the largest city, it has been growing by a rate of above 15,000 inhabitants per year over the past decade. So that is quite a lot for the size of the country, of course. If you look at the right side, you see an image of the Stockholm Royal Seaport, which is considered one of the largest urban development projects in Europe, with more than 12,000 new homes that are being built. So this is part of this growing or expansion process. So you may ask, but is there a consequence of this urbanization of in Stockholm? If you look at the left image, you see a map of the city. It's very complex from the point of view of planning, because the city is built over 15 islands. You see the Baltic Sea on the right, Mälaren Lake on the left. So this is very complex also in terms of atmospheric processes that are going on. On the right, what you see is a representation from our weather forecast model, Harmony Rome, at 1 kilometer resolution. So it means that, like in a photo, like pixels in a photo, the smaller the pixels, the better the image. Here, also at 1 kilometer resolution, we are already able to see features of the city, how it interacts with the atmosphere. And we are representing the mean summer air temperature in the year 2014, which is also not as extreme as 2018, but it was also significantly high. In these conditions, we can see that these reddish colors are showing temperature 2 meters high, and we see that the city is in fact warmer than the forest or the croplands around or the sea. This is known, as Mattia mentioned, the urban heat island effect. So there is one, and we have extensively validated these results against measurements. Now the question is, so if we know that the city is expanding, what will happen in the future? And we have been working closely with the municipality. We have developed different development plans for the future, and I will show just one. This is how the region of Stockholm will look like in the future, 2050, by the mid of the century. And you see that the city is mostly expanding south and north, not much densifying in the city center because it's already dense, but it's mostly expanding. It's mostly occupying areas that are now forests, and it will be more than 500,000 new homes that will be built. Now, the question is, what will be the impact in the future of this urbanization process? And what we did was we simulated the summer 2014. As I mentioned, it was quite hot. And then we replicated this simulation. So we did simulation again, but we changed the land use, considering how this region will look like in the future, in 2050. So we are not considering climate change. We have exactly the same forcing. And we are just asking ourselves, so if the summer 2014 would repeat itself again in the future in 2050, that the city has already expanded, how would be the influence over the climate of the city? And here we look just at temperature, daily mean temperature over the summer, and this is the difference between the scenario, so the future, 2050, and the actual baseline simulation 2014. The blue colors show small changes in temperature, up to 0.5 degree in average temperature for the summer. But then we see that these differences can go up to 1.4 in average. If we just look, if we filter out and just look at the nighttime temperature, because the urban heat island is mostly a nocturnal effect, these differences can go close to 2 degrees. That is one conclusion. The second, and which is relevant from the point of view of planning, is that this effect is mostly local, so we don't see a widespread effect. So we see the effect mostly over the regions that are urbanized, that are transformed. Then you may ask, but okay, 1.4 degrees in difference is not much. I mean, we can afford that. But let me show you the number of hot days, and this parameter was calculated based on the percentile 75th of the temperature. So the days with an average temperature above this threshold. And this again is the difference between our scenario for the future and the baseline. And you can see that in fact, over the regions that will be more densely transformed, we can have up to 10 more days, 10 more hot days in the future, just because of the land use change. No climate change effect here. So this can be significant. So we have shown that urbanization will change the climate. So how can planners work with this? And this is just an example similar to what Mattia has shown. And this is mean radiant temperature, which is a good indicator of thermal comfort. Sorry that, okay, now that's what you should see. And these are simulations with a very high resolution model called Solway that was developed in Sweden. A 2-meter resolution. So here you can see the actual buildings. This is an image from above. It's not very relevant to see the rooftops of the buildings. This is just for, yeah, if you are working with green roofs or solar panels. But from the perspective of heat stress, you see the streets here very hot, these reddish colors with 60 degrees in mean radiant temperature. This was the 26th of July 2014, the same year. But then if you look at shaded areas, areas that are shaded by the buildings, or this area in the center, which is an urban park, then you see that because of mostly the effect of shading, we can have a decrease in average of 30 degrees. This can be very, very relevant in terms of thermal comfort for the population, for pedestrians. If you want to know more about these, you can visit our CCs, and we have some showcases that are detailing a little bit more about these examples with high resolution modeling of these scenarios for the future, or the park cooling effect, and also the urban climate model that is behind this. And with this, I'm completed. So thank you very much for your attention.
Yes, I continue with links. We have seen for links quite a lot in the earlier presentation for the advanced screening. So we can keep a little bit shorter. Linz is a city with 200,000 people living there, with heavy industry, steel industry, and chemical industry. The whole area is 600,000 people, and there is still a steady increase from the past to the future. You see in the next slide. Yeah, this one. There we see the situation of Linz. Linz alone has 200,000 people, and we have an increase to expect till 2040 of 35,000 people, which is around 40%. And in the area, in the whole region of Linz, we see that we have now around 600,000 inhabitants, which will grow up to 2040 by additional 65,000 people, which is an increase of 11%. So the area, let's try again. I don't know why it doesn't work now for me. Earlier it was working, yeah. Now the area you see here, Linz needs an increase of housing, an increase of office areas, and what you see here is that the changes from 2017 up to 2022, which is the building, the construction applications that are shown for the last years. And here you see in the center of Linz a very high increase of to see additional housing areas, additional developments. So there is still an increase of density, which will be for the future even more problem than for now. Even in the outskirts of Linz, there is an increase of building area, so there is still through this urban sprawl additional activities to be seen, so that this urban heat island issue will become more severe. Let's try the next slide. Yeah. Here is just a scheme how the urban heat island issue is to be seen. We have earlier, it was just seen to have one city which has a difference of temperature to the surrounding area. Now we're looking in the city in a way that we show that we're looking into different places and see that we have very different smaller and larger heat islands with larger temperature peaks and lower ones. And here you see two lines. One is the day temperature and one is the night temperature. Over the day, you see quite a variation because of the different density of the buildings and of sealed surface in these areas. And you have in the center the highest concentration or the highest temperature. While if you look at this night time line, you see a steady increase at bell-shaped curve, but this is still a problem because if we don't have a reduction of temperature during the night time, then there is no relaxation for the population possible, and that there is that the people will have heat stress during the day and during the night, which is a problem for the health for the future. So let's go to the next slide. I don't know why it doesn't work for me. Yeah. We see here the situation of the summer days today and in the future for two different climate scenarios. You see that the bottom left image shows the situation now, and there you see there is the concentration, the number of summer days around 50 days a year up to 60. So it's in this yellow and orange area. Only few areas show higher numbers, and around you have these green areas which show even less, 40 or even 30 summer days. This means that in the prior time that there was a kind of a possibility to go to the outskirts to have less temperature, to have less hot summer days, and now that the situation is changing, it is increasing. You can see those pictures in the center. It shows the two scenarios: business as usual, the top one, and the effective measure scenario, the bottom one. In the years 2021 to 2050, the situation is quite similar. Yeah? We have an increase in this number of summer days. Now we have quite everywhere in the built-up area days 60 to 70 up to 80. Yeah? And if we go then to the next time range, which is 2071 to 2100, in this business as usual scenario, you see there will be nearly 90 to 100 days of summer days everywhere. Not just in the center, you can see it in the whole area. And if you look down to the business, to the effective measure scenarios, you have a slightly reduction. So these measures have an effect. Then we have numbers between 80, 70, to some extent 90, but we have still so areas around where we have 50 and below. So there is on the one side, climate adaptation is necessary everywhere, and it is especially then necessary if there will be not enough change in this greenhouse gas reduction. Let's go to the next slide. What we see now is the what we see now is this screening again. What we have seen in the beginning, again links, and what you can see here is that these maps, even it's just done by a kind of screening with a very coarse resolution. Yeah? We are now again in a kilometer or even lower resolution, and what you can see here is that we have here a similar pattern what we have seen earlier in this presentation with this 100-meter resolutions where we have seen these summer days. I think Dennis will add here some statements because his work he was doing that. Dennis?
Yes, I think the most interesting is this next slide. This is the expected impact from the screening, and we have these frequent, occasional, and rare events. And what is really interesting to see here is this is a 20-year event in the past. So this is where people died. Yes, it's 0.6 promille more mortality due to, according to our model, which is very simple. But the interesting thing is that when you look at these three here, so this is RCP 45, so that's kind of relatively optimistic for the for the end of the century. This is the worst case scenario for the middle of the century, and this is the worst case scenario for the end of the century. What we see here is that what used to be 20 years events in the past may become yearly or every 2 years maybe events in the future. And that's, in fact, this is kind of prediction which is consistent with more detailed modeling we had, and which is frankly quite concerning.
Yeah, it means that these rare occasions from the past are going to be frequent in this effective measures scenario, and even higher in this business as usual scenario. And therefore, it is necessary to discuss about adaptation measures for heat island cooling. Here we see on the left side this reference image, what we have seen two slides earlier. The situation of summer days 2071 to 2000, so the prior situation. And if we are going for land use change adaptation, yeah, which means increase of open green spaces, a reduction of sealed surfaces, increase of trees on the streets, etc., and increase of rooftop gardens. Yeah? This would lead to a cooling effect to have a reduction of these summer days of up to 10 days in this whole area. In the west more, in the center still we have 6 days or so. So we have the possibility to come in this future time close to the situation of today, to have less heating, to have less summer days. That is then somehow better to allow improving the health condition of the people, etc. What we are now going into detail is that we look what adaptation measures are possible and what would be the impact. And this we have done for several areas in links. You will see here now just one example where we have been looking in the historical center of links. Maybe you can switch to the next slide. Yes, we see it here. To the left, you see the situation now. Not that this was too fast. And to the right, there is the situation with the adaptation measures. Yeah, we have here, if I try to add the mouse here, yeah. Here is the mouse. Here you can see the increase of trees. We have here now growing a lot of bigger trees in this main place, which is until now just a flat area with only pavement, with nothing green there. So the idea was to have a look what will happen if we are going to plant here trees to make shadows there, and there's also other places where we have done this. Next slide shows the result of the simulation. Yeah, left side is the current state. You see in this in this big place quite high temperatures of 44 degrees mean radiant temperature. To the left side where we have no shadow, a little bit less, but to the right, going to put the image on the right side, we see here the adaptation impact. Yeah? Here we have all our trees, our new trees that would bring here a lot of reduction of heat. This was reduced to the mean radiant temperature from 44 degrees, what we have here, down to around 30 degrees, 32, 35. So we will have here you see the difference in detail. We have here the possibility to reduce the temperature of the mean radiant temperature of the whole 24 hours by around 12 degrees. Yeah? But this means that during the daytime, the difference is even higher. Huh? So in general, what we can say here, Linz is expecting a growth. Linz is expecting increase of heat exposure. With the climate simulation, we have shown what may happen without change. And with these simulations, especially with the microclimate simulations, where we have the possibility to assess what will be the impact of adaptation measures. Yeah? And we showed this quite distinctly, and the policymakers start to react in between. There were now two decisions. There will be a final support for establishing green roofs, that there will be even a fund of €1 million to make other measures happen. And what they also have done is of the central place. Now that there will come 30 trees, they will come this summer to provide here the possibility of cooling, to have less heat by shading this whole area. So I think this is quite a big success, what is now coming out of this project. Yeah? So I think I can stop here. Thank you very much. And I give it again to Dennis to have some final words. Thank you.
Thanks, Wolfgang. I would like to call all the other panelists as well here. And continuing on what Wolfgang was just saying, yesterday we had a webinar which was dedicated to Linz, which had much more details on this. And what we have learned on this webinar is that City of Linz has indeed changed its way of looking on climate change. And when we started this project, there were, well, not the people working with us in the project, but the political top of the city was very skeptical. Whereas during the last year, they have made 180 degrees change, and now they are proclaiming that they want to be kind of climate city of the future, which may sound silly if you see the Linz today, but I think 30 years ago when they said we want to have very good quality of air. It also sounded silly, and they managed. So this is a well-organized city, and now when there is a will, I think they will manage. And I also think this is one of the very big successes of the project. Now, I've seen one question which is interesting from the public, which is about this screening tool we were showing. And Pia, you were the most involved here on algorithmic side. We from AIT, we have developed a lot of software together with our friends from Kismet and Atos. So the direct question here is from Agnes Salvati, if she can test the tool. And yes, she can test the tool. We will contact everybody. So at the end of this webinar, there is a possibility for you to indicate how you would like us to contact you further or not at all. And one of the possibilities to say, I would like to test the tool. And I'm really saying here testing, because you must understand that while this is a really interesting tool, and this data which we were showing, for instance, for Linz, that was something I did earlier this week, and I'm not climate expert in any way. And so it works, but there are still bugs, there are still glitches, and we are looking for early adopters to help us to clean this up, and we would like to have really like controlled testing so that we also learn something from it. So anybody who would like to see this, now talking while being muted is not very useful. That's was I muted all the time? I don't know why I got muted. That's interesting.
No, only the couple of seconds.
Okay, I'm not sure where it got cut off, but just to repeat, if you would like to try this out, we would be very happy to give you a hand and to see how it works for you, to see what kind of issues you are having, and to have some improvements of the tool before we finish the project. Mattia, you have been using it quite a lot actually in Italy, in different cities. So how are your experiences here?
Try again, Mattia, should work.
Okay, I'm now.
Yeah, sorry.
Speak again, yes. So yes, well, we have started testing over several cities in Italy, and yes, we are pretty confident in the quality of results for the advanced screening. The reason why we have at the expert level is because we know that, of course, some bias are existing, but the validation process of the model was quite satisfactory on our side. And one other feature which I want to highlight, which is behind the methodology that we adopted, is that this solution is ready-made for future improvement in terms of data availability. We know that all models are heavily depending on the quality of data. And the way we have created this clarity model is that if one day we get better information on land use, or if we get better information on building materials and typologies, or on population, for example, statistics, our model, for example, is able to calculate different impacts depending on age of population or other weak population classes. But unfortunately, at the moment, this kind of data set is not available at the European level from a reliable and trusted source as Eurostat. So, for example, we are also talking with Copernicus and Eurostat because they were already thinking to different kind of data set that should be put online for open access. And that will be the future also of clarity. I mean, because that will definitely improve the quality of even of the advanced screening. That's why we are negotiating and talking with them for future exploitation.
Yes, and another interesting aspect is that this 500 meters resolution is arbitrary. Also, the 500 square kilometer size of the region which one can do advanced screening on is also very arbitrary. This is just a limit we have set so that we don't get too many expenses for our server calculations. But I'm pretty sure that we can go down to 250 or even 100 meters without having to change much. It's just a question on telling the system, okay, now you will do some more calculations. There will be more data. The moment there are any kind of paying customers, I think this is not a problem at all.
Yeah, the data package concept is designed to nurture and to feed the system with different kind of data, which respect the structure of the data set that the model needs to use and to calculate. So that's why I was saying we can survive even if especially if the data can be improved at the national and international level.
So we received another question from our dear auditorium for the experts, or maybe for you to discuss. There is a question how you convey uncertainty in the climate scenarios or any of the other data sources to the people who need to make decisions on. For instance, with uncertainty in terms of scenarios and data.
Claudia or Robert, you can pick this up while the tool.
Yeah, regarding the climate data,
you were a little bit.
Can you hear me? Yeah. So regarding the climate data, yeah. Here we've only shown well the ensemble mean, but what is also provided is the ensemble standard deviation. So all the climate indices were calculated actually by robot, most of them, for several Eurocortex projection, for several Eurocortex simulations. And then all these simulations, there was, well, an ensemble mean was calculated as well. So this kind of, it's not only one simulation that was run, but several simulations for the future. And so the ensemble mean is available that you can see here, what Dennis is just showing, and also the standard deviation, which gives you kind of an impression, yeah, how the models varied in their predictions. And that's probably what Dennis is just showing, yeah.
Yeah, I've got it. So this is for T90P ensemble mean, which is one of the indices, and on the left side is the actual index. On the right side is the
standard deviation.
And as Claudia was saying, this is a result of assemble of models. So each of them has a slightly different result, and then this is what comes out as a difference between them. And we have this for every index. So
and it is a very good question actually to ask, because that's one thing one has to keep in mind, that model predictions are not, there's not 100% sure that the future will look like this, but there's a variety that we have to take into account also for planning.
One indeed has to take this into account and take a look at it and see what the differences will be. On the level of advanced screening, I think we are not showing this data, so one has to really look at it at the level of the hazard indices.
Dennis, I saw another question, which I think it's interesting to reply because it's about the philosophy maybe of clarity and the use of it. Because there is one question about the fact, I mean, it's asking, the Clarity project has done a correlation between mortality rate and specific UTCI value. or this could be used, I mean, the Clarity platform could be used to analyze this correlation in different European cities. And I think this question, I mean, apart that, I mean, in terms of first answer, no, we didn't investigate the relation between mortality rate increase and specific UTCI value. But indeed, this is one of the exploration that could be done for different European cities. So this question is showing the potential of Clarity of answering to different kind of issue related to climate change and cities. And so this kind of statistics and this kind of studies can be done also because through the advanced screening, you're not only seeing the maps, but all the data, or I mean the main data, which is the one we can use, make it public, can be also downloaded in Excel format, for example, so that further statistics and extraction and analysis can be done on this data after the calculation is done. To be more specific about the relation between mortality rate and UTCI, one important thing is that different methods are behind this model. The mortality rate is a method which has been developed together with the experts from the National Italian Ministry of Health. We are working on this subject, and is basically calculated with a several, I mean, health discipline related approaches, which is basically calculating the increase compared to the standard mortality, something that we unfortunately learned to understand as a concept in this period of pandemic. So it's basically calculated the delta, the increase which is due with a certain degree of probability to the heat exact factor. While the UTCI is a calculation, as you all know, it's a very consolidated approach to calculate an index resulting from a variety of physical parameters. So the mortality rate is more statistically oriented, while the UTCI information is much more, let's say, parameter driven, physical parameter driven. So it will be interesting to compare both, because probably there will be some biases. Probably there will be some correlation to understand and read, but that's another brick to add more knowledge to the effect of climate change on cities, in my opinion. So it's a very good question in terms of, you know, which could be the potential use of Clarity. That's one which we never think about, actually.
We have an additional question related to decision making. It would be interesting to know if and how policymakers and decision makers are able to interpret and use this kind of uncertainty information. So how's the support for the non-experts on the subject?
Well, on some of the information, we are specifically introducing text, disclaimers, and description, which helps the reader to understand what the meaning of the data which are displayed, especially tackling the uncertainty, and especially tackling the needed, you know, integration of multiple results to have a full picture. So looking at the other variables, but then how they are translated into impact condition and risk condition. So the system, as it has been designed, includes a variety of, let's say, text-based specification. Some of them are related to the issue of uncertainty. And there is also always the possibility of having a sort of direct contact with the expert that developed the platform for more specific inquiries about interpretation of results. This can be connected to the testing aspect that Dennis was highlighting before.
I must highlight one more aspect, which
Okay,
is mortality. Basically, if I have a heat wave today with certain characteristics, some number of people will die. If I get the same one in a year, and if I start having it every year, it's not going to be the same number of people every year. People will adapt. Old people, people who are really very sensitive to heat, will die. The society will adapt. We will start sending people to old people to remind them that they should drink. We will organize some places where they will be safer than in their own homes. And so this mortality must be really taken with a lot of care. It's not really the future mortality, even if it would be ideal model. What it is, it shows like in the past what would happen if such a heat happens. It's not really completely good measure for the future, but we cannot do better. I mean, then you would have to add some kind of parameter saying, okay, by which percent does the society adapt to it through other measures, like, well, not having so many people who can die in the first place. And this is, I mean, this is a typical issue, but I think it's still valuable as long as one keeps this issue in mind. This is something which is inherent to this kind of modeling and just shouldn't be overinterpreted. Good. As I said, after this is over, you will be asked to answer a couple of questions, not too many. It's finished in a few minutes. Please do. We will contact you back if you answer the question saying we want to be contacted back, and we will not contact you back if you answer don't do it. We are really very serious about that. Also, the results of this will be online. We have now several of these results already from previous webinars, so you can immediately go and look at them. It's on Climate Adaptation channel in GoToStage. It's also on YouTube, so there is quite a few videos. There are also two upcoming webinars next week. One will be in Spanish, one will be in Italian. And you can watch, there are some really interesting, if you know German, I would really recommend you this yesterday's video from Linz. I've cut it a little bit, it's not ideal, but it's okay. It was really a very, very interesting webinar. This is the first one, which is giving a little bit more explanation on the project. This one is more discussion about the whole concept of climate services and marketplace for it. This was, unfortunately, I wasn't able to participate, but what I heard, that was a very, very interesting one. So we are collecting these things there, and also I would like to say that these webinars, if you have something which you would like to share with other people, talk to us. We are happy to invite other people to not only listen, but actually participate as co-organizers of these webinars in the future. That's it from me. Any other final words? I see this question about how policymakers and decision makers are able to interpret and use this kind of uncertainty information. So my first answer would be, well, policymakers probably aren't. They will need somebody to explain this to them. But I would prefer some experts to answer.
May I add a statement on this? Dennis?
Yes, please.
Yeah. The policymakers, they're looking very much into what is the overview and to some certain details. Yeah? And if they get a feedback from the public, they are very much interested to react on this. So this kind of activities we are doing here is a big contribution to the improvement of the cities. So all so we have done, we made the experience that in all of these projects where we show the heat island issues, all these policy makers are very alarmed about this now and are going to have solutions, activities they are providing funding, and so quite a lot of people are reacting on this. So it's just to see what may happen, yeah, and what could be avoided. Yeah. These two things are impossible. Are possible that the most important things that are asked for from such project.
Yes, indeed. We have seen this very clearly in Linz. We have seen this very clearly in Naples. So the moment they get presented the results and they understand the results, then they are worried and they are very happy to start looking at the adaptation options. And in my opinion, in the next 3 to 5 years, we will see really a big switch of many cities in Europe starting to really seriously take the adaptation options into account. Among other things, also because our results show that it makes sense. It may be expensive. You have seen the results from Naples, but it's not so expensive that we cannot do it. And the expected results are really very good. So we can really do a lot. And maybe Mattia and Wolfgang want to say a little bit more about that, but we have seen the presentations, and really it's clear that a large part of the heat increase, which is partially due to climate change and partially due to development of the cities.
Yeah, I just want to make a statement on your advanced screening. I was not so clear if this is a proper solution, but I found out that the results are really useful, and I didn't expect it. That we have such a high coincidence between this advanced screening, which is on low resolution with just a few data, and these expert studies where we can have a kind of similar pattern. Sure, if you go to the expert studies and compare this to the advanced screening, you can have the results more on this city overview, and to some extent on certain districts, you cannot go to a single building. Therefore, you need this extra. So you need these expert studies. But in general, this advanced screening is quite a big advantage, and it is really working all over Europe. Yeah? So there, everybody is then able to go to a certain city or a certain place to identify what may happen. At this level, I think that this is a great thing.
Yeah, there are many limitations of this advanced screening. It will never replace the fully fledged study, but not in every case a fully fledged study is needed or feasible. When you think of some smaller projects, I mean, you can do just for the area where the project is, you can do a quick study. It will cost almost nothing, and you get some new knowledge. You can improve the project. And it's more than doing absolutely nothing, which would be the result if only thing you had at your disposal was to pay for a fully fledged study, and your project is too small for that. So it's a tool which I think has a huge future. If not this tool, then somebody else will have to do something similar. Experts will always be experts. Expert studies will always be needed, but not every time, not for every project. So, anything else?
So just coming back to this question, to the uncertainty, I just wanted to mention there's the standard deviation, and also the different emission scenarios that are available in this platform for the climate indices, at least. Chance gives you a range how it may evolve, and that, as Mattia already said, is kind of described in text format, that this is available and this is what the users could have a look at to see the span, how the climate might change, or the different indices. But that's it, just.
Good. Thanks everybody for joining. I already mentioned that we will have two more webinars next week. one for Italy in Italian, one for Spain, which is absent here because they are looking mainly at traffic and not at urban infrastructure, which will be in Spanish and which we will have to repeat in English at some point. We will also be doing some more webinars really showing how to work with the tools, and there will be Swedish webinars in August, I believe, right, George?
I'm not sure if it is August. We need to confirm that. We are now in vacations period, so we'll have to see. But it will be, if not in August, in September.
It could be late August or early September.
Yeah.
We have also decided to continue with these webinars after the project ends, so there will be some more webinars in September and even October. And we will also have a real-world event at European, Andrea, what's the name?
The European regions thing in Brussels.
European Week of Regions and Cities.
Exactly,
European Week of Regions and Cities.
That's in October, and we would be very happy if you join us there. And well, that's it for now, I would say. Thanks for joining.
In my calendar, one more webinar starting at 1, but this is maybe a wrong thing.
No, that was by mistake, I think.
No.
Finish everything.
Okay.
So as for Thursdays, there will be a webinar which is not organized by Clarity next week. I'm still trying to find out the details on it. We will publish it also on our webinar site as soon as we have the details. So next week in the same time slot, there will be another webinar. It's, I think, mostly organized by Yaro, this one, but as I said, I'm lacking details, so the moment we have it, we will announce it. So thanks everybody for joining.